In this video, I wanted to take you through the concept of contextual compression retrieval mechanism, where we can create a summarized version of the context that has been retrieved from the vector DB. So, in this video series, which is a LangChain crash course, so in the past few videos, we talked about like how to build a semantic search, then how can using a LLM we can do a RAG, we can build a RAG. And then in the last video I talked about how to build a better RAG using some advanced concept where we will add in the metadata while building the RAG, which will kind of enable us to do a better retrieval, right? So but we have seen in the last video that if you are passing on a query, so the whole page content is being retrieved and it has been shown as an output to which may not be readable and which may not be easy to comprehend. So to use the concept of contextual compression retrieval, what it will do is once the page content is retrieved, it will create a summarized version of that page content, and that will be displayed as an output to you, right? Which will be much more easier to understand and much more easier to comprehend, right? Now, without further delay, let's get started. So here are like few regular installation. Then I am using Llama 2 quantized version here. So I have tried this concept of contextual compression retriever with Google Palm 2, but I have seen that we are getting better results if we use this Llama 2 model. So Llama 2 7 billion chat GPTQ version model I am using here. And again, the big shout out to the block. So the block is doing some amazing work, and they are kind of creating this quantized version of the LLM models, and they are releasing in the Hugging Face Model Hub. So with that, I will create a LLM out of it. So we have gone through this process so many times in this series, so I will skip that. Then we are creating an embedding model using the sentence transformer. And then as I have done in the last video, so I am creating this document along with extra informations which are like metadata information for each of these papers, and we are adding extra informations like name, year, the author. Then we are also adding informations like the field, like the paper belongs to which field, and it talks about what are the different topics of machine learning, right? So I have created this using this link, and where like top 20 papers are described and given details. So I picked up those details. So the citation numbers may not be accurate, but just that I have used this links values as a kind of a reference for this rack creation, right? So once we add this extra information as metadata, then what we will do is we will create a contextual compression retriever. So this contextual compression retriever will need two things. One is a base compressor, which we will need to pass here, and also a base retriever, right? So the base compressor we will create using the LLM. So using this LLM chain extractor dot from LLM, where we will pass the LLM and we will create a compressor. Then we will pass it here as one of the parameters of which is nothing but a base compressor. And then we will also pass the vector DB, which will act as a retriever, and we will try to do the retrieval from this vector DB, which is nothing but a chroma DB, which we have created earlier, right? So with that, now let's try to explore how this contextual compression can help us. So without using anything, I'm just doing a semantic search on the text. So using the vector DB, I am just doing a similarity search, and I am passing a query which is like, please let me know the details about batch normalization, right? So with that, you will see the whole page content from every matching document has been retrieved, right? And this is a lot of text to read and very hard to understand also, right? And it's like the whole page content is retrieved, right? So there is no summarization which being involved here. Now using this compression retriever, what we can do is you can do the same thing, like we can pass our query to this compression retriever dot get relevant documents, and we can get back the result. So once we get back the result, so if I just look at the first page content, right, the first document's page content, you will see it is much more summarized version of the page content, and which is much more easier to understand, right? So the output is like the key idea is randomly drop units from the neural network during training, right? So it is much more concise and much more easier to understand summarized version of the page content, and instead of bringing the full page content and then showing you the output, right? So similarly, like for the second document, it talks about like a residual learning framework, deep learning, deep neural networks, layers, and learning residual functions. So these are like the summary from the second document, which is retrieved. But I feel the first page content, the first document's page content is much relevant to our question, and that we can use as for a downstream task, right? Now, this is for the documents which I created was very small in nature, right? So if you see the page content is nothing but the summary which is giving in this specific link, and the summary I have used as a page content. So I just wanted to check how the contextual compression retriever works if we are passing on a large document like a PDF, right? So here I am just adding one of the papers, which is a survey of large language models. So that is a PDF which we will create an embedding, and then that embedding we will add back to the vector store, right? So here just creating that document using PyPDF loader. Then we are doing a character text splitter. We are splitting that the whole document by a chunk size of 1000 and with a chunk overlap of 200, right? And then we have the chunk documents, and using the vector store, we will add back this chunk embeddings to the base vector store, right? So this is the way to do this db.add documents, which will add the newly created embeddings to the vector store, right? Now, if I again just do a db.similarity search, which is just a simple semantic search, and I ask a question, please let me know how the large language models are trained. So you will see this is a huge page content, right? So the whole page content is retrieved, and which will be much more time consuming to read. So instead of what we can do is we can use this contextual compression retriever, and we can pass our query and we can get back results. So if I just loop through each of the documents page content, you will see it is much more concise in nature, right? So first two document outputs are not much related and not much accurate, but the third and fourth documents summarized version of the page contents are much more relevant to our question, right? So it talks about like the training process for LLM involves various techniques as masked language modeling, next sentence prediction, and text generation, right? So this is basically the three techniques which we generally use if we are trying to build a LLM using some training process, right? So here the summarization is quite good, and the outputs are quite good. And also for the last document, it also talks about like different LLM like ChatGPT 4 and how it has been trained on different vocabulary, and all those details are given as an output in a much more concise way, right? So I hope you got an understanding why you need to use a contextual compression retriever, and which will give you like a kind of a summarized version of the page content instead of splitting out the full page content, which is very hard to comprehend, right? So with this, I will end this video. I hope you like this video, and please like this video in case you found this useful, and also subscribe this channel if you haven't. Thank you all. Thanks for your time. See you in the next video. Thank you.